This table illustrates the different levels of molecules or in different substances, comparing their levels in the plasma, filtrate, and then in urine. So you're not responsible for knowing these numbers, but they are there to understand why we need tubular reabsorption and tubular secretion. So for example, if you follow the process of glucose levels in the plasma is about 100 milligram percentage. That milligram percent is the milligram of a substance per 100 milliliters of solution. So just pay attention to the numbers as opposed to the units. So the glucose in plasma is at about 100. The amount of glucose in the filtrate is 100, which means that in the glomerulus, all of the glucose is filtered and will eventually be eliminated through urine unless we reabsorb it back. So the amount of glucose that ends up being excreted in urine is 0. And the kidney does that by reabsorbing 100% of those glucose back into our plasma. That is obviously in non-diabetic patients, but in diabetic patients, because they have their glucose levels are way too high, some glucose is eventually going to be spilled into urine. If you compare that with creatinine, which is a toxic metabolite, our plasma has about 1 milligram percent. Filtrate, all of it, 1 milligram percent. But there's still more in those capillaries, so we have to actively secrete them into urine. So our urine ends up having about 196 milligram percent. And again, that shows you the difference between the reabsorption process and the secretion process. So here you can see what's going on in relationship between the tubules and the blood vessels. So again, you can see the filtrate passing through the proximal convoluted tubule, and you can see the exchange of different things. So that blue arrow represents reabsorption, tubular reabsorption, where things that are important to the body, like all of that glucose that is found in the filtrate, needs to be reabsorbed. So the direction of flow of substances in tubular reabsorption is from the tubule into the interstitial fluid into the peritubular capillaries. And about 70% of tubular reabsorption does happen in the proximal tubule. If you compare that with secretion, those would be the toxic metabolites like the creatinine that the body needs to get rid of. And the direction of flow in tubular secretion would be from the peritubular capillaries to the interstitial fluid, eventually going into the tubules to be excreted in urine. Now, tubular reabsorption, and again, that is to keep the important molecules and preventing their loss in urine. You want to know the direction of flow on tubular reabsorption and the methods of flow. So there are 3 different methods. One is active transport, where the important molecules are going to be actively transported from the tubules into the interstitial fluid and then into the capillaries. The only problem with active transport is that we need a transporter. We need a carrier. So we are limited to the number of the carriers that we have. So, there's a capacity of these carriers. And that is why in diabetic patients where there's way too much glucose in the filtrate, the number of carriers, so glucose is eventually going to get dumped into urine. Some glucose will start to appear in urine, and that's why diabetic patients that are not controlled would have glucosuria. Same applies to amino acids, creatinine, lactic, citric, uric acids, and ascorbic acids, and some ions are all going to be reabsorbed through the process of active transport. Now, water is going to follow by osmosis, and some small proteins are going to be reabsorbed through the process of endocytosis. Now, here you can see the process of sodium and water reabsorption in the proximal tubule. You see here all of the filtrate, and in the proximal tubule you see sodium being reabsorbed through that active transport. So the active transporters that are reabsorbing glucose, for example, are piggybacking on the sodium ions. So sodium is being reabsorbed, and with it, it will pull some water with it. So water is always going to follow sodium through osmosis. And sodium, because it's a positive ion, it is also going to pull with it some negative ions like chloride, phosphate, and bicarbonate. And because in the proximal tubule there is reabsorption of both sodium and water, the filtrate that ends up being at the end of the proximal tubule is isotonic filtrate, because again, we are reabsorbing sodium and water at the same time. So there's no change in the tonicity of the filtrate. Now, tubular secretion, which again is the elimination of waste products from the capillaries to the interstitial fluid to the tubules, that occurs through active transport. So you can see here how there is the active transport of potassium in exchange of sodium in the distal tubules. Another thing that is secreted would be these hydrogen ions, and that obviously is important in order to maintain a proper pH of the body fluids. And I will see you folks in the next tutorial.